Okay, problem number 4 on homework 6 says a rifle with a muzzle velocity of 460 meters per second is fired from ground level at an angle of 53.1 degrees. Part A says what is the velocity, and that's going to include the magnitude and the direction, of the bullet at its maximum height. B is how many seconds does it take for the bullet to reach its maximum height. C is what is the maximum height of the bullet, and then D says find the following just before the bullet hits the ground. We are going to answer questions A, B, and C on a new problem exactly like this, and then we're going to answer D in a separate clip. So what I'm going to do is make up some new data. So let's say that my initial velocity is 948 meters per second. And let's say that it's at an angle of 62 degrees to the horizontal. Okay. So if we draw a picture of what's going on here, I'm going to go ahead and there we go. And it should look something like this, right? So that is our trajectory. It's the parabola that's going to represent our trajectory. We know a couple things. Overall, we know that the velocity down here is going to be 948 meters per second. That I'm not going to draw the angle in here, but that the angle to the horizontal that it's fired at is 62 degrees. The reason I'm not drawing it in there is because as soon as it's fired, that angle is going to change, and it's a kind of a mistake to put it in there because it does not last longer than the instant at which the projectile is initially fired. So this is going to be 948 meters per second, and I'm going to label this 62 degrees. This is going to be velocity y initial, so that's my initial velocity in the y direction, and I'm going to call this Vx, okay, because that's the velocity in the x direction. So if I want to solve for Vyi and Vx, I'm going to have to use my trigonometry. And I know that the sine of 62 degrees is going to be equal to the opposite, that's Vyi, over the hypotenuse, which is 948 meters per second. So if I want to solve for Vyi, that means that it is equal to 948 times the sine of 62 degrees, and that's going to be in meters per second. Alright, so if I go ahead and calculate that out, I have 948 times sine 62. It gives me 837.03. So Vyi equals 837.03 meters per second. Okay. That is going to be my initial component of the velocity in the y direction. Note that this one changes as soon as the bullet's fired and decreases. So if I want to find the velocity in the x direction, I'm going to use the exact same thing, except instead of saying sine, I'm going to say cosine. Other than that, I know cosine 62 equals Vx over 948. So that means that'll just be cosine. So I'm going to go ahead and say Vx equals 948 meters per second times the cosine of 62 degrees, and that's going to give us 445.06. You do need to make sure that your calculator is in degree mode. We're not using radians. Alright. So if I go ahead and write a couple things down on here, I'm going to kind of write a bunch of stuff all over this diagram, things that I know. And if it's fired from ground level, which is kind of set up in the problem, that means that right here, these are my x and y components of velocity. So velocity y at this point is equal to 837.03 meters per second. And I'm going to call that Vy initial again. I know that my acceleration over the entire thing is going to be negative 9.8 meters per second squared. And I know that to this point right here, or at that point right there, my velocity in the y direction is equal to 0 meters per second. The reason that I know that my velocity at the very, very top of the trajectory here, or at the highest point, is 0 is because I fire it into the air with an initial velocity going up. As everybody knows, what goes up must come down, which means that at some point it's got to turn around and change direction. At the instant that it changes direction, my velocity is going to be 0. So at the highest point, my velocity is 0. At that point, it's going to change direction, come back down. My velocity here is going to be negative 837.03 meters per second. And I'm just going to say Vy equals that at that point. So I have it drawn in the picture so it's not like all random wherever. These represent my velocities at specific points. My acceleration is the same the entire time within the y direction. It's always down at negative 9.8 meters per second squared. My Vx is going to be the same across. So it's going to, if I had a shadow on the ground, that shadow would move at the same velocity the entire time. So a couple other things that we want. What we're looking for is, well, to answer A, it says what's the velocity, the magnitude and direction of the bullet at its maximum height. Since I know that my Vy at the maximum height is 0, my answer to A is actually going to be 445.06 for this example. Note that the values of the numbers are different on the actual homework assignment. But for this example, at the very top, my Vx is 445.06. So if I draw a quick triangle that represents my velocity at the top, this is going to be exaggerated because my y velocity is 0 meters per second. My x velocity is 445.06 meters per second. All right. So if that is 0, and I use the Pythagorean theorem to find the resultant vector, it's going to be 445.06 meters per second as well. 0 squared plus 445.06 squared is going to give us 445.06 squared. Square root of that gives us that. Okay. We also know that this is going to be 0 degrees. Okay, because there's no velocity in the y direction. Obviously, this wouldn't make a triangle. If this were actually 0 degrees, it would simply be a straight line. But for illustrative purposes, I've gone ahead and drawn it differently like that. So for part A, it would be 445.06 meters per second at 0 degrees. All right. Remember, a vector includes magnitude and direction. Okay. So part B and C, or parts B and C, say how many seconds does it take for the bullet to reach its maximum height, and then what is the maximum height. So I'm going to go ahead and write down the rest of my variables here. I have t equals question mark. Velocity final is question mark. Nope. Velocity final in this case is going to be 0 meters per second. And the last thing that I wanted was delta y. Alright, and that's going to be my displacement. I'm going to grab a different color marker here for this part because what we're looking at when we want to solve B and C is only this part right here. Okay, we only care about what's happening within this box here. Anything outside of that box is useless to us as far as B and C goes. And the reason is because if we were trying to find how much time it took to get to its maximum height and we use this velocity down here, well, the difference in height, all right, i.e. the change in its position on the y-axis between this point and this point is 0. They're both at ground level. 0 minus 0 is 0. So what I've got to do is find its displacement in the y direction at this point where Vy is 0. So we go to solve this. If we want to find how many seconds it takes to reach its maximum height, we're going to use the equation that does not have delta y in that. So in order to use one that does not have delta y, we're going to use the first kinematic equation, and that is Vf equals Vi plus acceleration times time. Alright, this one is the easiest one to use. Vf is 0. Normally I'd go ahead and cross through that, but since it is the only thing on the left side, I'm going to say 0 meters per second equals, my initial velocity is 837.03 meters per second plus, parentheses, negative 9.8 meters per second squared times time. Alright, so that means I'm going to subtract 837.03 from both sides. Alright, that's going to cancel it out on the right side and leave me with negative 9.8 meters per second squared times t. On the left side, I get negative 837.03 meters per second equals negative 9.8 meters per second squared. And put it in parentheses so it's all nice and clean, times time. So if I want time on its own, since I'm multiplying it by negative 9.8, I have to divide it by negative 9.8. Alright, and make sure you include your units in there. It's going to cancel out on the right side. Meters per second on the top is going to cancel with meters, and then my seconds squared. So I'm still left with a seconds to the negative 1 on the bottom. Since that's in my denominator, it's going to move up to the top. And so time ends up being 837.03 divided by 9.8, and that gives us 85.4 seconds. So time equals 85, no, I'm off the screen, time equals 85.04 seconds to maximum height. Part C says, what is the maximum height of the bullet? Alright, you can use time if you want to on this. We have 4 kinematic equations that we're looking at. If you want to use time is 85.04 seconds, you could say, and I'm just going to write it down here because you could do it, delta y equals Vf plus Vi over 2 times t. I'm actually going to go ahead and do that because I kind of like this one. We don't use it very much anyways. Or at least I have a habit of not using it as much, so I want to improve my proficiency and go ahead and use it more, right? You guys should do that too. Delta y equals Vf. My final velocity is 0. Do I have to include it in there? No, I'm going to go ahead and just mark it off and say that it's 0, right? So it's going to equal my initial velocity, 837.03 meters per second, divided by 2 times my time is 85.04 seconds. Alright, so what's going to happen is my seconds are going to cancel out there, and I'm going to put 837.03 divided by 2 times 85.04, and that's going to give me 35,746.25 meters. So delta y equals 35,746.25 meters. So that is 35 kilometers up into the air, which is pretty stinking high. Something that we should note on this, if I'm looking at solving this a different way, I can go ahead and solve this. I did it earlier with another one. I can use, instead of that, the third kinematic equation and do Vf squared equals Vi squared plus 2a delta y. I'm going to get the same value. In this case, I would be using acceleration. In this case, I don't use acceleration. I use the time. Alright, I'm going to go ahead and stop the video, and we're going to pick up the next one on another video.